Campbell, and today we're going to be talking about box and whiskers plots. Let's get started. All right, we're going to jump right in with an example. First of all, let's consider this list of numbers. We have 1 through 10, basically. Okay, the median we know is going to be the middle value. Now there's 10 values, so the median lies halfway between 5 and 6, or the fifth and sixth values. So therefore our median is going to be 5.5. This splits the list into 2 halves. So the lower list is going to be 1, 2, 3, 4, 5, and then the upper list is going to be 6, 7, 8, 9, 10. So the median of the lower half is going to be 3, and the median of the upper half is going to be 8. So these numbers, together with the median, cut the list into 4 quarters. And we talked about that before. These are our quartiles, or our percentiles. So what is a box and whisker plot? So a box and whisker plot is formed by placing vertical lines at 5 positions corresponding to the smallest value, the first quartile, the median, the third quartile, and the greatest value. Might be a good idea to write that definition down in your math journal so you don't forget it. All right, next what we do is we draw a box between the position of the first and the third quartiles and horizontal line segments, or whiskers, that go out of the sides of the box, and they connect the box with the 2 extreme values. It's actually really simple. Sounds complicated, but it's simple. So here is the box and whisker plot for the integers 1 through 10 that we talked about at the beginning of this video. With a box and whisker plot, you can see the distance from the first quartile to the third quartile. And this is another way to see the interquartile range. A box and whiskers plot shows the measure of the spread of the middle half of the data. All right, let's look at another example. Harika is rolling 3 dice and adding the numbers together. She records the total score for each of 50 rolls, and the score she gets are shown below. Display the data in a box and whisker plot and find both the range and the interquartile range. I'm not going to read all those numbers to you, don't worry. So if you need to, you can pause it and take a look at them. All right, so here's our solution. First, what we need to do is put the list in order from least to greatest. Since there's 50 data points, the median will be the mean, or the average, of the 25th and the 26th values. And you can see them, they're highlighted in yellow, 10 and 11. The median will split the data into 2 lists of 25 values, and we can write them in 2 lists. Now, since each sublist has 25 values, splitting the 2 smaller lists, the first and third quartiles of the entire data set, can be found from the median of the smaller list. For 25 values, we're going to split into 2 groups of 12 numbers, and the quartiles are given by the 13th number from each smaller sublist, 9 and 13, and those are highlighted in yellow as well. There's our list again, just so we can refer to it. From the ordered list, we can see the 5-number summary that we're going to need to make our box and whisker plot. The lowest value is going to be 5, the first quartile, 9, the median, 10.5, the third quartile is going to be 13, and the highest value is 17. So our box and whisker plot is going to look like you see there on the picture at the bottom. And the range is given by subtracting the smallest value from the largest value, so 17 minus 5 equals 12. And the interquartile range is given by subtracting the first quartile from the third quartile. So 13 minus 9, 4. Okay, let's talk about representing outliers in a box and whisker plot. Outliers, it's really important to understand because they can really skew how we draw conclusions about our data. So box and whisker plots can be misleading if we don't take outliers into account. Again, you might want to write this down in your math journal. An outlier is a data point that does not fit well with the other data in the list. So for box and whisker plots, we can define which points are outliers by how far they are from the box part of the diagram, and you'll see it a little bit better in a minute. All right, let's look at an example. The box and whisker plots on the next slide represent the times taken by a school class to complete an obstacle course. The times have been separated into boys and girls. The boys and the girls each think they did the best. Give the following information for both the boys and the girls. we're looking for the lowest value, the first quartile, the median, the third value, and the highest value. And then number 2, give the reason why the boys or girls think they did the best. Okay, so there are our box and whisker plots. So comparing two sets of data with a box and whisker plot it's relatively straightforward. So for example, you can see that the data for the boys is more spread out, both in terms of the range and in their interquartile range. See how the box part is actually larger and longer than the girls. Now let's take a look. The 5-number summary for each is shown in this table. So for the boys, the lowest value is 1 minute 30 seconds. The girls is 1:40. First quartile, 2 and 2:30, 2 minutes 30 seconds. You can see the rest for the median, the third quartile, and the highest value. And if it helps you, you can pause this video and see how those numbers correspond to the box and whisker plot. All right, so here are some points that each side could use in their argument. Here's some of the things that the boys could say. The boys had the fastest time. They had 1 minute and 30 seconds was their fastest time. So the fastest individual was a boy, so that could be part of their argument. The boys also had the smaller median, which was 2 minutes and 30 seconds, meaning half of the boys were finished when only 1/4 of the girls were finished. Since the girls' first quartile is also 2 minutes and 30 seconds. So in other words, the boys' average time was faster. However, let's take a look at the girls. The boys had the slowest time, 5 minutes and 10 seconds. So by the time all the girls were finished, there was still at least one boy completing the course. And the girls had the smaller third quartile, which was 3 minutes and 20 seconds, meaning that even without taking the slowest fourth of each group into account, the girls were still the quickest. There you go, guys. That's just about everything you need to know for this lesson on box and whisker plots. Thanks for joining us. We'll see you next time. Bye-bye.